Hello, and welcome to our lesson on drawing and interpreting histograms and pie charts. Today we are going to expand our skills in visualizing data, which will help us analyze and compare datasets more effectively. In this lesson, our primary focus will be on understanding how to draw and interpret histograms and pie charts. We'll begin by exploring the components and construction of histograms, noting how they differ from bar charts. Next, we'll learn the key steps to create pie charts and how to interpret the data they present. So far, we've covered some crucial ground. Data terminology. We've learned about populations, samples, discrete and continuous data, as well as primary and secondary sources of data. Grouping and organizing data. You now know how to arrange data in a meaningful way. Visualizing data. We've explored frequency tables, time series graphs, pictograms, and bar charts, which are foundational skills in representing data. For example, suppose you have gathered data on the heights of students in a class and wish to see the distribution pattern. Histograms would allow us to do that efficiently. Similarly, if you want to visualize the distribution of students by their favorite subjects, a pie chart can clearly show each subject's proportion. By the end of this lesson, you'll be able to create and interpret histograms and pie charts accurately, equipping you with essential tools for data analysis. Let's get started. Let's dive into the main concepts of this lesson, how to draw and interpret histograms and pie charts. A histogram is a type of bar chart used to represent the frequency distribution of continuous data. Unlike bar charts, where bars do not touch, the bars in a histogram are adjacent to each other, indicating that the data is continuous. To draw a histogram, start by setting up the axes. On the x-axis, we represent the class intervals or bins, which are ranges of continuous data, and on the y-axis, we have the frequency density. Frequency density is a measure of frequency per unit of data in a class interval, which is equivalent to the equation frequency density equals frequency divided by class width, where class width is the interval range, such as 0 to 15,000, 16,000 to 25,000, and so on. On the x-axis, we mark the class intervals, taking care to represent the size of each interval accurately. Note that with histograms, unlike with bar charts, we can have varying interval lengths on the x-axis. So, since our first interval has a width of 15, this will have a wider base on the x-axis than the 15 to 25 interval, which has a width of 10. For each class interval, calculate the frequency density using its formula. For example, if 10 people earn between 0 to 15K, then the class width is 15, and the frequency density is 10 divided by 15, which equals approximately 0.67. Plot the frequency density on the y-axis for each class interval and draw bars that touch each other to represent continuous data. By following these steps, you ensure that the area of each bar, not just its height, accurately represents the frequency of the data within each interval. This method helps prevent misleading visuals that could arise from disparate class widths. Let's move on to pie charts. A pie chart is a circular chart divided into segments, each representing a proportion of the whole dataset. It's particularly useful for comparing different parts of a dataset as a whole. To construct a pie chart, start by calculating the total frequency, which is the sum of all individual data points. Then convert the frequencies of each category into angles. The formula for the angle of a segment is this. Angle for a segment equals frequency of category divided by total frequency times 360 degrees. So fill in the table according to this formula. We now move on to actually drawing the pie chart. Start by drawing a circle and a line from the center to anywhere on the circumference. Use a protractor to measure and mark each segment's angle using a protractor. Draw a line from the center to the edge of the circle at these angles. Continue marking and dividing the circle until all segments are represented. Additionally, we often include percentages on each segment of the pie chart, which can be calculated as angle divided by 360 times 100%. Interpreting a pie chart involves comparing the angles to understand the proportion of each category. You can convert angles back into frequencies for exact values by reversing the angle calculation. By following these guidelines, you can create both histograms and pie charts to visualize and interpret data effectively. Let's dive into some examples to solidify our understanding of drawing and interpreting histograms and pie charts. First, let's start with histograms. Imagine we have a dataset showing the heights of 30 students grouped into intervals of 5 centimeters. The histogram diagram provided shows the height intervals on the horizontal axis and the frequency of students in each interval on the vertical axis. Look at the histogram. Notice how each bar represents a height interval, such as 150 to 155 centimeters, 155 to 160 centimeters, and so on. For example 1, we will interpret a histogram. According to the histogram, how many students are between 160 and 165 centimeters tall? To answer this, we simply look at the bar corresponding to the 160 to 165 centimeters interval. If the height of this bar reaches up to, say, 7 on the vertical axis, then there are 7 students in this height range. Example 2 is creating a histogram. The task is to draw a histogram for the data shown. To draw this histogram, first, label the horizontal axis with the height intervals. Label the vertical axis with the frequency. Draw bars for each interval with heights corresponding to the frequencies given. So for the interval 140 to 145, draw a bar up to 2. For 145 to 150, a bar up to 5, and so forth. This visual representation will help you see the distribution of students' heights. Example 3, interpreting a pie chart. What percentage of students prefer math if the pie chart shows a sector for math that covers 90 degrees? First, recall that a full circle is 360 degrees. To find the percentage, first divide the degrees of the sector by the total degrees in a circle, which is 90 divided by 360 equals 0.25. Then, multiply by 100 to convert to a percentage, which calculates that 0.25 times 100 equals 25%. So, 25% of students prefer math. Example 4, creating a pie chart. Create a pie chart illustrating the data on favorite subjects shown. To create the pie chart, first, calculate the total number of students. Then, find the angle for each sector. Maths equals 90 degrees. English equals 45 degrees. Science equals 135 degrees. And lastly, history equals 90 degrees. Finally, draw a circle and divide it into sectors with the calculated angles. 90 degrees for maths, 45 degrees for English, 135 degrees for science, and 90 degrees for history. By following these steps, you'll have a pie chart that accurately represents the data. Through these examples, you can see how to tackle typical GCSE questions involving histograms and pie charts. Practicing these skills will help you visualize and interpret data more effectively. In today's lesson, we explored how to draw and interpret histograms and pie charts, essential tools for visualizing data. We began by understanding histograms, noting that they are used to represent the frequency distribution of continuous data. Unlike bar charts, the bars in histograms touch each other, showing the continuous nature of the data. We learned to set up axes, calculate frequency density, and draw bars that accurately reflect data frequencies. Next, we moved on to pie charts, which are useful for showing proportions within a whole dataset. We discussed how to calculate the total frequency, convert frequencies into angles, and use a protractor to draw the segments of the pie chart. By comparing the angles, we can understand the proportion of each category within the dataset. We applied these techniques to an example dataset on incomes, constructing both a histogram and a pie chart to visualize the data. This hands-on practice helped reinforce our understanding of the steps involved in creating these charts. Overall, this lesson equipped us with the skills to create and interpret histograms and pie charts, enhancing our ability to analyze and present data effectively.